So today we're looking at Unit 8, Lesson 13, with our aim being able to solve real-world problems with scientific notation. About it says, the average American household spends about $40,000 each year. If there are about 1 times 10 to the 8th households in the U.S., what is the total amount of money spent by households in a year? We know that everyone is spending $40,000 each year, and there's a total of 1 times 10 to the 8th people, or households. The question is asking, what is the total amount of money spent by households in a year? So we need to find the total money that people are spending. We can find that the money spent per household, multiply that by the number of households. So again, the money we spent per house is $40,000. And we know that there's a total of 1 times 10 to the 8th households. We have this dilemma where we have one number in standard form and one number in scientific notation. What should we do in order to multiply these numbers together? We learned yesterday how to multiply numbers in scientific notation together, so why don't we go ahead and do that? So first we'll need to move 40,000 into scientific notation. So I know that my multiplier should be between 1 and 10. So let's have my multiplier be 4. I'll need to move my decimal place over to find my powers of 10. So I have 4 times 10 to the power of 4 multiplied by 1 times 10 to the 8th. We can rearrange and group our multiplier together. So 4 times 1. And then group our powers of 10 together, times 10 to the 4th times 10 to the 8th. Obviously 4 times 1 is just 4, and we're going to add our exponents together. So I have 10 to the 4 plus 8, which means my answer is going to be 4 times 10 to the 12th. This question is asking the total amount of money spent by U.S. households in a year. So 4 times 10 to the 12th doesn't really make sense. Expand 4 times 10 to the 12th power out, I get 4 with 12 zeros behind it, or 4 trillion. So that's how much money all U.S. households are spending in a year. Answer should be that U.S. households spend 4 trillion, or 4 times 10 to the 12th power, dollars in a year. So let's come up with our key points today. What can we do to easily solve real-world problems that have very large or very small numbers? Our key point for today is going to be that we can solve real-world problems with very small or very large numbers by using scientific notation. Go ahead and turn to your interaction with new material. Interaction with new material example 1 says, the distance from the sun to the earth is approximately 96 million miles. The distance from the sun to Mars is approximately 141 million miles. How many times further is the distance between the sun and Mars compared to the distance between Earth and Mars when they're in line with each other? Okay, let's go ahead and break down the information that this problem gives us. So we know that to begin, we have that the sun to the earth is approximately 96 million miles. I'm going to go ahead and label that on this diagram that I have here to help us keep track of all of our distances. We know that the distance from the sun to Mars is approximately 141 million miles. The problem is asking us to compare the distance between the sun and Mars and the distance between Earth and Mars when they're in line with each other. So we know the distance from the sun to Mars. We know that's 141 million miles. We need to be able to find the distance between Earth to Mars. In the diagram, I can see that 141 million is the longest distance that I have, in that the distance between Earth and the sun at 96 million is part of the way between the sun and Mars. So I can find this other missing part of Mars to the Earth by subtracting my total distance of 141 million by part of the distance there, 96 million. The steps that we'll need to take is to first subtract 141 million by 96 million to find the distance between Earth and Mars, and then compare that distance between Earth and Mars to the distance between the Sun and Mars. First, we need to recognize that we need to move all of our numbers into scientific notation. As a tip, just remember that a million is the same as saying 10 to the 6th. So since I have millions for all of these numbers, I can go ahead and just say 141 times 10 to the 6th for the distance between Sun and Mars. In my subtraction, I can say 141 times 10 to the 6th minus 96 times 10 to the 6th. Obviously, our numbers are not in proper scientific notation, but because we have the same magnitude in all of our values, it'll be easy to subtract and compare. So let's first obviously subtract. We have our distance and we have the same magnitude, so that'll stay the same. And I can just subtract my magnifiers. So 141 minus 96 will give us 45. So I know that the distance between Earth and Mars is 45 times 10 to the 6 miles. Now that I have my two distances, 141 times 10 to the 6 and 45 times 10 to the 6, we can compare our two values in scientific notation. Remember that when we compare our numbers in scientific notation, we first will compare our multipliers by dividing those out. So I'll have 141 divided by 45. And I know that's approximately 3.13. Once we've compared our multipliers, we can go back and compare our powers of 10. So I have 10 to the 6th divided by 10 to the 6th. So since those are the same value, I'll know that those divide and just equal 1. Remember our steps from Monday, so once we've compared our multipliers and our powers of 10, we need to go back and multiply 3.13 times 1 to see how much larger our distances are. So I have 3.13 times 1, and that just gives me the answer of 3.13. Since our answer is 3.13, I know that the distance between the Sun and Mars is 3.13 times longer than the distance between Earth and Mars. So remember that when we're dealing with very large or very small numbers in real-world problems, we can simplify our work by using scientific notation. Go ahead and complete your independent practice in your exit ticket on Google Classroom now.